Okay, today we're going to start talking about 812, which is more graphs of polynomials. And really, this is what you guys have been discovering on your own this week. So hopefully the activities that we did helped you kind of make these ideas make sense. The whole goal is for you to be able to graph this stuff without using a calculator. And when I say graph it, I really mean sketch. I don't want it to be a really complicated graph. Okay, and I'm going to tell you today exactly what I'm looking for. So, this first one, 826 part A, P of x equals x plus 10 times x plus 7 times x minus 3. That means it's going to cross the x-axis 3 times. Okay, so 3 times, either 1, 2, 3, or 1, 2, 3. Now obviously it's not going to be a straight line and it's not going to be sharp, but I want you to think about making sharp ups and downs, mountains and valleys, when you figure out that this has 3 factors, 3 zeros, 3 roots, 3 x-intercepts. Okay, now the orientation, this is a positive out in front, so that means on the far right side of the graph it goes up. So that's the one it's going to look like. So when I sketch this graph, I don't care anything about the y-axis at all right now. All I care is that you know that x plus 10 makes an x-intercept at negative 10, x plus 7 makes an x-intercept at negative 7. Clearly not drawn a scale, but that's okay. And x minus 12 gives us an x-intercept at 12. Now remember, it ends on the right side going up, so this is going to end going up. I go to the far right 0, or intercept, and I go up. Now it's just like a needle and thread. I'm going to go backwards, so it's going to go through the 12, through the negative 7, and through the 10. And I'm not going to make it sharp, I'm going to curve it. And every time I get to the next 0, I'm just going to needle and thread and I don't know, swerve its way through. Okay? So B, same thing, but this time we have 4 factors. That means this is a 4th degree. This one's a 3rd degree. If I multiplied these out, and I don't want you to do that, it would be x times x times x, giving us x cubed, or a 3rd degree. This one, x times x times x times x, would be a 4th degree. So again, remember, it's either going to go down, up as a W, or up, down as an M. Either one of those is going to be a 4th degree. Again, it's not going to have points, it's going to be curved. So, which one is it? Is this a positive or a negative? Definitely a positive. So it's going to end on the far right side going up. So it's going to look like a W. It's going to cross through negative 6, negative 3, positive 5, and positive 8. Now remember, the right side is going up, so I'm going to end by going up on the far right 0, and I'm just going to needle and thread my way through. Down, up, and it's a rough sketch looking like a W. Okay? Part C, 1, 2, 3, 4, a 4th degree. So again, it's either going to be a W or an M. Okay? 1, 2, 3, 4, or 1, 2, 3, 4. But this negative tells me on the far right side it's going to go down. Far right side it's going to go down. So this one's actually going to look a lot more like an M. So here's my graph. Again, I don't care where it crosses the y-axis even a little bit today. I've got negative 4, negative 2, positive 6, and positive 10. Okay, on the far right side of the graph, it's going down. Now I'm going to just work my way backwards. Needle and thread, up, through, down, through, up, through, down. Okay, rough sketch, that's all we're going for today. Getting the correct orientation and the correct x-intercepts. Now, this one, x and x, you might think it's a degree 2, but remember, this is squared and this is squared. So x squared times x squared, that's actually going to be an x to the 4th. So again, we're either talking about a W or an M. Okay, which one is it? If it's positive, it ends on the far side going up. That makes it a W. So, it only crosses the x-axis at 2 spots, negative 7 and positive 7. Okay, on the far right side, it's going to go up. This time, though, because there's a squared with x minus 7, the 7 is actually going to do a bounce. So it's going to end by going up, but it's going to bounce off the x-axis. And then at some point in time, I have to turn it around because I have to bounce it off the x-axis over here. Okay? And the reason this one is also a bounce is that there is an x plus 7 squared. There's not always, if there's one bounce, it doesn't mean everything bounces, but in this case, there's 2 squareds, so there's 2 bounces. Okay? E. This is the last one in this question number 26. 1, 2, 3, 4, 5 x's. If I multiply them all together, it will be x to the 5th. So let's see what that's going to look like. Either up, down, up, down, up. So 1, 2, 3, 4, 5. Or down, up, down, up, down. 1, 2, 3, 4, 5. Okay? It's a positive orientation, so it ends by going up. So that's what it's going to look like. Okay? I got more space on this board. So remember, -6, 3, -3, +5, +8, and +12. On the far right side, because it's positive, it will end by going up. I don't see anything squared, so I'm not going to have any bounces. I'm just going to needle and thread my way through. Okay? Far right side, it's going up. Just make my way through these x-intercepts. I don't care how high up you make your mountains. I don't care how low. They don't have to be even. They can be even. I just want to sketch. I want it going through the right x-intercepts. And again, I don't care about the y-intercept at all today. Okay? You should be able to do all of this with no calculator. Next, as you guys were talking through your videos today, I could tell you guys were getting the hang of this, but I just want to make sure you really, really know what you're doing. This question for number 27 is saying, well, what's the maximum number of roots that an equation can give you? So, for example, if you have a degree of 3, and we just talked about that a little bit. So, you could have x cubed. You could have x cubed plus 2x squared. You could have x plus 2 and x minus 3 and x plus 1. That would also make an x cubed. That would also make a degree 3 polynomial. You also might have something like an x2 squared and then an x minus 1. Okay, because that's x squared times x. All of these are degree 3. Now we can talk about what the actual roots are, but for every single one of these, the maximum number of roots is 3. Okay, so we don't have to do any work. Find the highest degree. Notice this is a degree of 3. I don't add those exponents because these are not being multiplied together. Okay, so the highest degree for any of these, the highest number of roots, because the degree is 3, is 3. Okay, so think about, what if I had something that was x to the 4th? Okay, what's the highest number of roots I might have if it was x to the 4th? Okay, maximum of 4 roots. The most it could cross the x-axis is 4 times. Okay, what if I had y to the 27th? What's the maximum number of roots? Oops, not y to the 27th. Y equals x to the 27th. Okay, my maximum number of roots is 27. So in other words, whatever this number is, if we call it n, if the degree is n, then the maximum number of roots is n. Okay, and that's going to become pretty important in this lesson and the next lesson. I also want you to think about how many roots these actually have. Okay, because I'm telling you the maximum number of roots in this case is 3, but how many roots does it really have? So this graph, you guys have done a lot. This is one of our parent graphs. Y equals x cubed is just the cubic function. Okay, how many times does it cross the x-axis? Just once. Okay, we know because it said x cubed, it could have up to 3 roots. In this case, it only has 1. I'm actually going to take this off for a minute. I'm going to make this a little bit easier. You don't need to be able to factor this right now. You should be able to, but I'm not worried about that today. If I factor this out, it's going to look like that. Okay, this x means it's going to cross at 0. This means it's going to cross at -1. And really, because there's a squared here, it's going to bounce. Okay, it's a positive orientation, so it's going to end going up. I know it's bouncing, but I have to turn it back around and go through this other one. That's my sketch. How many times does it go through the x-axis? It has 2 real roots. Okay, this one we just did a whole bunch of equations like this. I'm not even going to do the whole thing. It's positive. Positive orientation, so it's going to end by going up. I'm going to go backwards. 1, 2, 3. So that's a super rough sketch. I didn't even put my X's in, but that could have 3. Okay. This one is going to be similar here because it has 1 bounce and it has 1 through. So the maximum number of roots always matches the degree, but it could be fewer because of bounces or lounges. Last question I'm going to talk about on this video is question number 8-28, and we're talking about the minimum degree based on a graph and the orientation. Okay, so we just talked about this. The minimum degree that's possible here is just figuring out the shape. So if we're talking about degree, 1, 2, 3. So I'm counting each up and each down. So that means it has to be at least an x cubed. And we'll talk about, well, when will it be more than an x cubed later? But it for sure has to be at least x cubed. This one is going up and then down. So it for sure has to be an x squared. 1, 2, 3, 4. So that one has to be at least x to the 4th. This one, 1, 2, 3, 4, and 5. So that one has to be at least x to the 5th. Okay. Orientation we've already been talking about in this video, and you guys seem to have a good idea. Orientation means is it positive or negative at the beginning of the equation, and we only care about the right tail. Okay, the right tail. On the right side of this one, we're going up. That means this is a positive orientation, a positive equation. This one on the right side is going down, negative. On the right side going up, positive. On the right side going down, negative. So when you're checking out orientation or you're checking out an equation, you're looking for the right side behavior only. Okay, that is it for this video.